Hi, welcome to Jumping into Solutions. Today we're going to be talking about whether you need to go to a larger electric panel upgrade when going electric. Our guest expert, Tom Kabat, an energy engineer, is going to talk about the ways you probably don't have to if you go with more efficient energy appliances. The following videos show you some of these appliances, starting with induction stoves. Now, there's a lot of people out there that don't know what an induction
Yeah.
stove is,
Yeah.
me included. So,
Yeah.
can you please tell me how it works?
Yeah. So how this works is, and they're all different kinds of stoves and ranges, but induction basically means that it only turns on if there's a pot or a pan on the burner.
Wow.
That's the same size as the burner,
Mhm.
and then you can turn it on. And so when it's on, if you take the pot off, that burner will turn off. And it's because the heat is conducted magnetically.
Oh,
The heat pump system is about thermodynamics. Heat seeks cold. And there's a liquid in here that is under high compression. It's under compression and draws warm air from cold air. And so it's really cold up here, drawing warm air from the garage. And there's a little benefit in the summertime. It helps cool the garage a little bit.
Police because I'm red. I'm more concerned about everybody in town knowing that I'm driving a red car and where I'm going with my red car, and then hearing about it later.
So basically, how does the electric vehicle work?
I plug it in,
Okay.
and I have a charger on my wall, and I plug it in usually when I am about half down on charging. I have been asked how long it takes to charge the car, and I truly don't know, because either I charge it during the day when I'm busy doing things in my house, or I charge it at night.
Can you tell us how they work and details about where they go in the house, stuff like that?
Okay, well, I have two sets of solar panels. The ones that you're seeing here I put in 2022, and they're microinverters, and they automatically, in each panel, there are 8 of them, convert the sun's energy from DC to alternating current. So it's directly into the house. The panels that I installed in 2013 are on the side of the house here, and they are direct current, and they go into an inverter in my garage. So I now have enough solar power to power my new electric car, as well as my heat pump and all my, I'm totally carbon free in this house, so.
Wow, I noticed they look quite different than your new panels you have up here. So,
Yeah.
is there a substantial difference, or they're pretty? Because these you just put on. What was it? Did you say?
2022 for the 8 microinverters.
Okay.
So yeah, they're more powerful. Well, we are in a very cold winter time,
Yeah.
even though it's March. And what this component is doing is drawing, believe it or not, warm air from the outside.
Wow. Okay.
How? Because in here it gets really cold, colder than the outside air.
Oh, wow.
And whatever warm air is in, down to I think 30 degrees.
Oh my goodness! Wow.
It will, and I don't think it's 30 below, but 30 degrees, it will draw heat from the outside, pulls it in, goes under here, and then it goes up to my attic.
Wow.
Where we have the compressor and the other components of the system.
I see.
This does both air conditioning in the summer and heating in the winter.
Okay.
It's called a mini split system. Very efficient.
Hi, everyone. I want to thank Pat Toth-Smith for the great overview of all the different ways we can electrify our home and our vehicle. And now, how do we put all this together? How do we do all this? I mean, it seems sort of complicated and complex to me. And we have today Tom Kabat, who is an energy engineer, who is going to give us a nice overview of how to get started with electrifying our home. And I would like to let everybody know that our video is intended to be an introduction, Tom has several videos that are way longer, way more complex that you are going to want to dive into probably when you decide to do this. And hopefully we'll decide to do it pretty soon. So welcome, Tom. It's a pleasure to have you. And let me start off with our first question, which is, what is the first thing we should do when we decide that we want to start electrifying?
Well, thanks, Kathy and Pat. It's really a pleasure to be here talking with you again about these things. And so really when you want to get started in this, there's kind of two ways to get into it. One is where you have plenty of time, and the other is because something breaks and you need to replace it. And that's what you're focused on, is that one thing that just broke. But if you have time to start before something breaks, the place to start is making a plan. And making a plan will help you get all of your end use needs met. And that end use needs is my utility jargon for things like hot water is one of my end use needs, and cooking, and mobility, being able to power an electric car, and clothes drying, and, space conditioning. So HVAC, heating, ventilation, and air conditioning. So getting those needs met. So what I recommend people do, if you've got time, is start by making a plan. And that means looking around the house at the existing equipment you're using to meet those 5 end use needs, and seeing what it would take to replace each one of those with that clean electric alternatives. So then making a plan will also help you budget out how much panel capacity. And I've got my little example 100 amp electric panel right here. It's a disconnected prop, so when I touch it, it's okay for me to touch it. You guys don't want to touch your own on the insides. Like, don't touch the shiny bits inside. Anyway, but when you're looking at your panel and you're trying to see, oh, do I have space? A lot of people get confused and think they don't have any space because visually you can't see what's going on there. But what we found by looking at the data is most homes are using only 1/3 or 1/4 of their electric panel in actual capability of the panel. And their panel might look kind of full with the number of breakers in it, but you'll see we've got a slide on 11 ways to get more stuff onto the breaker. So there'll be lots of ways to do it, but I definitely recommend starting with a plan.
So what if I don't have a plan? Can I still start doing things right away?
Definitely. Okay, so the way to start without a plan, let's say something breaks, it's to pick the power efficient alternative for replacing it. Let's say your water heater breaks, because that, at my house, that is the one emergency where we don't have a great contingency plan. If the cooking breaks, we can go out to dinner for a while and order takeout. If the space heat broke, we could use little resistance space heaters. If the dryer broke, we could use a clothesline. So we've got all these backup alternatives for other things, but not the water heater. So if your water heater is getting old, I recommend replacing it now, but even maybe before you make a plan. But pick the water heater that uses up the least amount of panel space. And the way to do that is to pick a heat pump water heater that's got a big tank to store water and a little compressor and backup heater with it. So then it's able to go, we've got now 120 volt versions that can go on the regular outlet, and we'll be showing you those. And then there's also the 240 volt more common ones. And they are just like in a regular electric resistance water heater with this little module on the top that's really a backwards refrigerator. It sucks heat out of the air, say in the garage around it, and takes that heat and jacks it up to a high temperature and puts it into the tank to heat the water. So, if you don't have a plan, you've got to be ready for whatever breaks first, and then put the power efficient version of getting your needs met there. That'll leave plenty more space on your panel for the other projects.
We're going to be able to show people what you've labeled a small reversible plan that shows sort of, different low voltage appliances that you could do. And your total cost of these is way less than I would have thought to electrify.
Yeah.
I mean,
maybe I'll talk about that little small reversible plan idea. So people were asking me, is there anything I could do that isn't a big commitment. And so I took a look at those 5 end uses, and what we saw is, well, there's now 120-volt versions of all 5 of those things. So at the top of the list, there was the shared circuit heat pump water heater. That's what HPWH stands for. I tend to recommend getting a big tank to store lots of hot water energy, but having, one of these low powered versions, so it's got lots of time to reheat the big tank. But I got all my needs met out of the big tank. And so my needs are all met. I don't care how long it takes to recharge the water heater. Anyway, those are available at Lowe's and Home Depot at actually, I just saw them around $2,300. And so you could do that. There's also 120-volt window heat pumps. I've got one upstairs in my house, and they have a big cost range. Mine is down at the low end, but I've seen some really nice ones at the high end. But you can install those yourself. It's like a window air conditioner with a 2-way reversing valve in there to heat you in the winter by pumping heat in that it extracts from the yard, and cool you in the summer by extracting heat from the house and rejecting it outside. Then
Yeah,
there's
I think Pat,
Yeah.
you just got something like that, didn't you?
Yeah, absolutely. It's interesting you're saying that, because we did buy a 120 amp one, and it is a very low level one, but it keeps our house, as I said in the previous video, really, really warm, because I have it now in the wintertime. I mean, it does have limits because we bought it to go to 42 degrees. So if it goes lower, we do have to supplement it with a little radiator type heater. But other than that, it's actually warmer than what my gas central heating was, ironically. But, it's nice that you described how the fan will pull the warm air out and bring the cold air in for the air conditioning, and vice versa, because I do feel the difference with the fan motion that you're talking about. So that's really neat. And so this brings me to a question that I had, is about, I mean, do you have to upgrade your panel? And so, when you're considering these things, is this something that you have to do?
Definitely not. What we've been noticing is most panels are not that highly loaded. But most electricians make money upsizing your panel, so they might be telling you need to upsize because they can make money doing that. But we found that through careful design and selection of the equipment, you can usually fit it all on. And so the longer videos that we've put out show people how to go about doing that. And also at the end, we'll have links to a web app that helps do that, and also to a website at Redwood Energy Partners that has an onboard spreadsheet that helps you do it. So there's lots of ways to get you a little help doing those calculations that help show the building department and yourself that everything can fit on the electric panel. With these 120-volt options that we were just talking about, like your 120-volt plug-in window heat pump that you were mentioning, Pat, you don't have to get a panel upsizing for that kind of thing. The building code just considers that part of the regular 3 watts per square foot of load that they calculate into the panel anyway.
In general, if it's under 3,000 square feet and in a mild climate, like a lot of California is, it should be fine to have a 100 amp panel. Are there some panels that you probably would want to upgrade?
Yeah, probably 60 amp panels and below for single family detached houses. That's a bit small. You can fully electrify on them, but you'd have to do almost all of the little tricks we have. And I kind of look at that adventure and think, oh, who's going to want to do all the tricks when they get there? Because, after all, we are Americans and we want everything big. So I tend to let people go ahead and pursue upsizing if they've got the money and the time and want to do that. But upsizing your electric panel can be anywhere from, say, $3,000 to $30,000. It just depends on your situation and your electrician. The very high end of that is for underground wires going to your property. And if you need to retrench that and put in new, bigger wires to feed your house. But if you've got overhead power lines going to your panel. And so then that's a lot cheaper. So
Okay.
that's down at the $3,000 to $5,000 range.
Now, do most people have 100 amp panels?
Most people have 100 amps or more if
Okay.
their house was built, say, in the 1970s or later.
Okay.
And they haven't, it could be an older house and it might have 100 amps or more if it got remodeled sometime in the last 30 years. So lots of us have panels that are 100 amps and larger, and 100 amps is enough for a big lifestyle. And so that's what we find, but it just takes a little attention to details of not getting oversized power jumbo equipment and getting the stuff that'll meet your needs, and uses, say, the bigger tank instead of the more powerful resistor.
I see.
And like the heat pump, you get a more efficient heat pump instead of that sips electricity instead of a less efficient heat pump that gulps electricity.
Okay.
So those
I
are the
think
kinds
I
of
might have
things.
gotten the second one. I wish I'd planned a little bit more.
Yep.
So
Yeah, well, especially here in California, we've got these high electric rates, and so there's a lot of reasons to go efficient in your heat pumps, just to keep your operating costs down, and then to keep your capital costs down on the panel upsizing. And so take those capital cost savings from panel upsizing, plow them into the better equipment, and pick better equipment and fewer projects.
I wish I had seen this video a few years ago before we replaced our water heater and our gas furnace. It might have saved us some money.
Yeah, a lot of, the market's evolving pretty quickly. So like the 120-volt water heaters are pretty new. They're just been on the market a year now.
Yeah, we
And
had to put
but
in a whole 240 outlet,
yeah,
but now I wouldn't have to do that. I could just get a 120-volt water heater out there.
and a lot of people can make it a do-it-yourself project and really save a bunch of money that way.
Wow.
So, and I mean, that's what I did at my house. But
So I know that we've gone through a few things about, picking energy efficient equipment, picking very, water, energy efficient water heaters, dryers, avoiding oversizing. And you mentioned a combo washer and dryer as all ways to free up amp space on your panel. But you've also talked about things like circuit sharing. I don't have any idea what that is. Can you talk a little bit about that?
yeah, so the idea of these circuit sharers are that they would come off of one breaker on the electric panel. And this is a hardwired circuit sharer. I'll show you a plug-in one in a moment. But here's my electric panel, and this side would be connected to the electric panel, and the power goes in. And then this side is always available. Let's say we wire that to the dryer outlet. So when the dryer turns on at any time of day, it got power. And then when the dryer turns off, any leftover power then freed up is available on this line for something like the EV charger or the water heater. And the reason I mentioned those two as the ones to go as kind of second class and get the leftover power is each of those has onboard storage. Your car has an onboard battery, so it doesn't care which minutes it gets the power, but sometimes we care what minutes we get our clothes dry. So we're in a rush to dry clothes, whereas we're not really in a rush to finish heating the water heater tank or the car charging. Both those have big storage. So that's one version of, we call it hardwired.
And there would be extra water in your water tank.
Right.
So
You've got,
hot water
because
already.
the car's probably still got, 100 miles of range in it, and the water heater's probably got, another 3 or 4 showers in it too. So it's just adding and expanding that up to 4 or 5 showers worth. But I thought I'd show this one is a plug-in version of that same thing. You can see the big power cord plugs in.
That's the biggest cord I've ever seen.
Yeah, so this would plug into the dryer outlet or something like that. And then just to show there's it's just a short cord, and then it's keeping this outlet always available for the dryer. And when the dryer turns off, the cord stays in, but then this outlet activates to finish charging the car. So the car is getting seconds out of it, and the dryer if that was my priority, was getting the first power out of it. And that little circuits sharing device I just showed is under $190 now. So
Wow, so that's a
whereas,
lot cheaper than $3,000 to replace your.
oh yeah, yeah. And then the hardwired thing I was showing, this is $650.
Hmm.
And then there's one more version of that, which when we're trying to save power on the panel, it's another hardwired version. It looks a lot like the other one, but it's got these two power sensing clamps that go up on the wires leading into the panel. And so then when the panel got loaded up to 80% or higher of its loading, it would cut off the flow going to the car charger. So this thing is monitoring the panel and turning off when the panel's getting up to 80% loaded. And that might happen once or twice a year during your giant cookie baking party with the heat pump on and all the doors open and everyone's showering at the same time, whatever that party's like. Anyway, that's the time, the 1 or 2 times a year, the car charger would pause. And it would check back every 15 minutes, like, is the cooking done yet? It'd be seeing, did the loads drop? Can I restart the car? So those are the two big, control approaches to fitting everything on the panel. Most of what I talk about is an efficiency-based approach, which means right-sizing the equipment and picking the lower consumptive power versions of equipment.
Right. So it sounds like a lot of this is with water heaters, and then I'm looking at one picture that also shows a washer dryer combination.
Yeah. So I love those things.
One
So that's
machine.
Yeah. I love those combo washer dryers, and I've got the LG version of that. It's only 4.3 cubic feet only. That's a very big washer drum. And we put dry, dirty clothes into that one machine, and we get dry, clean clothes out.
Wow.
Now with my version, my LG brand one, it's just a condensing form of drying where it kind of overheats the air in the dryer, and then that gets moist, and then it tries to condense on its drum, and then it pumps the liquid water out. So it doesn't have a vent to anywhere. So it's just a box that can be in any room of the house. It doesn't have to be near the wall or anything, and it can dry clothes right where it is. Mine takes longer, like 2.5 or 3 hours to do a whole wash and dry cycle. But the one in the picture we just got for our daughter, it's a GE brand one with a built-in heat pump. It runs a lot faster. It's about 2 hours from putting clothes in to getting dry, clean clothes out. And it's more powerful. It's able to do the work in 2 hours, and she really likes it. It's even better at managing lint for her furry little pets.
Wow.
So
And oh, I'm sorry, Pat, go ahead.
I was just going to say, so it's just one drum for both?
Yeah, it's the same drum. I mean, actually, just to wrap your head around it, imagine if instead of a dishwasher, you had 2 machines side by side. The other one's the dish dryer. And so after you wash the dishes, you come and you move all the dishes over. How long would we be doing that? So once you go over to these single devices, the combo machine, you just don't want to go back. It's kind of like it's primitive to have to go handle wet clothes. Why do I want to be assigned that task in between and maybe leave moldy stuff someday if I forget? Again.
And the heat pumps are so efficient. I mean, it probably would cost you much less than the double, having the double ones.
Oh, the other thing I say here in the Bay Area is it also frees up $10,000 worth of floor space. So
Yeah,
I got that little thing
great
going
for
for
small
us.
apartments.
That'd be
Yeah.
great for my
Yeah,
house.
this is a very big drum too. 4.8 cubic feet is very big for a washer drum, but that's the same drum that's going to be doing the drying.
Well, I think there are a couple of things here for people who live in apartments that are very appealing. One is this combo washer dryer, and another is the basically the heat pump that fits in your window that you don't need to do any rewiring for. You just plug it in and you got your heating and air conditioning right there, just like a window air conditioner. That to me is a game changer, because how much was yours, Pat, when you put it in? How much did it cost?
Gosh, it was under $500 and my husband
I
put
mean,
it
that's amazing.
in.
That's
Yeah.
amazing. So, Tom,
Yeah.
we've got a whole list of equipment silver bullets, and
Well, yeah,
we've gone through a lot of these already, but
yeah. One thing I did want to talk about, one slide in the deck, is the one that's the graph of the 5 different end uses and the different levels of power efficiency, and just to try to help
Mhm.
people see what there is to see on that graph. And so on the left side, it's describing, the different end uses like drying and cooking, hot water, etc. And then next to it, it's got several different equipment alternatives to do the drying or to do the cooking. And then it shows in the length of the blue bar on that graph, it is showing the amount of power in watts of power that is counted on the electric panel in the electric code. And I've applied all the different coincidence factors already to this graph, but it shows you the wide range of panel impact these different choices have, and why I'm such an advocate of taking a look at the power efficiency of the equipment and picking those things that get your needs met, but only take a little bit of panel space in capacity and leave you lots more space to meet the rest of your end use needs. And the big one is car charging, but the thing people don't really understand about car charging, and have built it into the graph, is that these car chargers, if you're using them 8 hours a day, and our cars are home more than that many hours a day, most of us, that the big 50 amp charger that everyone seems to lust after is enough for 100,000 miles a year of car charging, and none of us want to drive that far. So it's kind of overkill. A 20 amp circuit delivering 16 amps of electricity gives you 39,000 miles of driving per year. And, I might have time for a quarter of that, but, I don't need anything more than that. So just people getting used to the idea of, we're not playing Indy 500 at home for the car charging.
right,
We got the time. Let's let the machine do its job. And then that lets that avoids overloading the grid. And so your neighbors in your neighborhood grid, they can all electrify. And that's what's going to save our climate, is our
right,
neighbors electrifying after they see how
right.
well we did it. So
Well, plus not only getting a small, I mean, I use a 120 to charge our car, but also when you're talking about these circuit breakers or the circuit sharers, so your car just stops charging while you run the dryer. I mean, that's fantastic.
yep. Yeah.
Um,
So this stuff is getting easier. And that's what I try to tell people is, you can make it complex, but if you just right size the equipment and pick the power efficient things, then you kind of avoid the whole expensive problem of dealing with your utility to try to get everything upsized and finding an electrician to do that.
okay, so for people like me who like, talking about amps and our panels, it's all sort of
Mhm. Yeah.
Latin. Well, I probably
And
understand Latin better than I do this. Who can help us figure all this stuff out?
yeah, so we hopefully we'll have a slide in there that'll show a couple of links to a few tools where we can do it ourselves, and a few companies who are offering kind of concierge services. One of them is called quitcarbon.com, and they offer statewide concierge service that they don't charge the homeowners for. They make it back from the contractors that they end up recommending. And then there are next door groups that people can start up and have peer-to-peer information exchange. Who did you find for a good electrician to do this kind of stuff, and answering those questions, or what kind of heat pump did you use. And so we're seeing these next door groups start up. There's even a Facebook version called Electrify Everyone, but that's national, so it's harder to get your little local results. But in the who can help thing, we also put a link to my business partner, Josie Gaylord. She has developed a web application called Zero Carbon Home. And so you'll see a link to that. And that's a tool that you can use and build your own electrification plan and take pictures of the equipment that you've got already and put it in there and look through the equipment lists and pick the ones you want to use, and then use that plan like a shield to defend your panel and to explain things to your different contractors who would come in to do the projects, so they know how much space they get on the panel and they don't put in something that takes up more than their lane.
Are there rebates out there available? And do you want to wait for these rebates to do something, or what are your thoughts on that?
Yeah, thanks. Yeah, there's definitely too many rebates now. It's confusing. So there's a great website now administered by the Building Decarb Coalition, and the website is called the switcheson.org, I believe, and we'll provide a link to that. They have a rebate finder and you put your zip code in. And so they've mapped it out for what rebates apply in your zip code for the technology you're looking at, let's say water heaters. And then right now it's late 2023, but this is going late 2023 through most, hopefully all of 2024. There are rebates statewide for up to $900 for heat pump water heaters from something called Golden State Rebate, and then another up to $3,800 or more if you're low income, but up to $3,800 for 65-gallon heat pump water heaters and larger. So between the two of those, there's plenty of money there. And then there's some local incentives depending on your zip code and your community choice aggregator or your utility, whoever it is who's offering these more localized incentives. There might be another, $1,000 or $2,000, depends on what they're offering. So there's lots of incentives. I feel like we're at peak rebate. I'd say go now. If you're wanting these technologies, do not wait. But late in 2024, maybe early 2025, the state will try to roll out some new low income programs. So if you don't have a need now and you're low income, you might want to wait. But if you're not low income, you probably ought to take advantage of the good stuff now. There's even tax credits for leftover costs. If the rebates aren't covering the whole thing, the part they don't cover, you can get a 30% tax credit on a lot of these. But
Well, I mean, the climate can't really wait for us
Well,
to.
I can't wait at all.
yeah, that's another good point. And up here in the Bay Area too, another good point on water heating is the more activity we can build up right now, the better it is for helping us transition to the new clean air appliance rules that are coming out, that where they will clear off the bad gas devices from the distributor shelves. And so those won't be an option to replace it. When your gas thing burns out, your plumber will be going to get the new heat pump water heaters and whatever qualifies, because the old polluters won't be legal anymore after 2027.
Yeah. And I think, one of the reasons we're all doing this is not only because in general, I think you save money over time, especially if you've got a solar system, but our gas appliances are really methane appliances, and that's a really potent climate polluter. I mean, it's like 80 times CO2. So it's a really good thing to do right now.
So I wanted to thank you for coming here, Tom.
Yeah, thanks a lot, Tom. It was great.
Well, thank you for the chance to share all this. It's changing fast, and I'm glad you guys are looking into the ways that it is changing and how to share that with your community.
Yeah, and I do want to remind everybody that Tom has much more extensive videos on this subject on his website. Can you remind us the name, Tom?
Yep. Redwoodenergy.net.
Thank you.
And please go to our website, because this episode will also have information about rebates. It's www.jumpingintosolutions.com. So thank you.
Thank you.
Yep. And so redwoodenergy.net.